Momentum is a commonly used term in sports. A team that has the momentum is on the move and is going to take some effort to stop. A team that has a lot of momentum is really on the move and is going to be hard to stop. Momentum is a physics term. It refers to the quantity of motion that an object has. A sports team that has a move has a momentum. If an object is in motion, then it has momentum. Momentum can be defined as mass in motion. All objects has mass. So if an object is moving, then it has motion. It has momentum. The amount of momentum of an object is dependent upon two variables: how much stuff is moving and how fast the stuff is moving. Momentum depends upon the variables mass and velocity. In terms of an equation, the momentum of an object is equal to the mass of the object times the velocity of the object. In physics, the symbol for quantity momentum is the lowercase v. Thus, the above equation can be written as P is equals to m times v, where m is the mass and the v is the velocity. The units for momentum would be mass times velocity. The equation illustrates that momentum is directly proportional to an object's mass and directly proportional to the object's velocity. The higher the mass, the greater momentum. The greater velocity will increase the momentum. The units for momentum have mass and velocity. When it will multiply, you will have kilogram meter per second. This is consistent with the equation for momentum. Let's have an example. Two vehicles are on a downhill. A truck has a 14,000 kilograms of mass and 2,000 kilograms for a car. They will be sliding on this hill. You will see that greater mass has greater momentum. Another example. We have two water bottles here to knock down with two objects, the ball and toy bullet. The ball has 0.4 kilograms, and when we throw, we will use 2 meters per second velocity. A toy bullet has a mass of 0.03 kilograms, but when we will use to shoot the water bottles, the speed of it will become 45 meters per second velocity. Let's try to throw a ball. And let's try the toy gun. You will see that also much higher velocity can have greater momentum. We take the equation. For the ball, we have the mass of 0.4 kilograms and a velocity of 2 meters per second. Transpose from the equation, P is equals to 0.4 kilograms multiplied by 2 meters per second. And you will get the product of 0.8 because it is multiplied the 2 units, kilograms and meter per second will combine. It will become the momentum of 0.8 kilograms meter per second. And for the toy bullet, the mass is 0.03 kilograms with a velocity of 45 meters per second. Transpose 0.03 kilograms multiplied by 45 meters per second. You will get an answer of 1.35 kilogram meter per second. When we compare, you will see that the toy bullet has a greater momentum to knock down the water bottle. Another example. A box full of toys with a total mass of 6 kilograms is sliding on an inclined platform with the speed of 0.75 meters per second. How much is the momentum of the sliding box? We will use the equation P is equals to M multiplied by V, which is the mass is 6 kilograms and the velocity is 0.75 meters per second. Then multiply and get the product. So the momentum of the box going down is 4.5 kilograms meter per second. The jeepney is traveling with a speed of 15.28 meters per second and a total mass of 8,800 kilograms with the driver, cargo, and the passenger. What is the momentum of the jeepney's movement? We have the mass 8,800 kilograms. We have the velocity 15.28 meters per second. Let's solve. Transpose it first. Momentum is equals to 8,800 kilograms multiplied by 15.28 meters per second. Solve, and you will get a product of 134,464 kilograms meter per second. Which of these two solid balls can fall down a movable Doric column with a mass of 72 kilograms? The bowling ball has a mass of 7.35 kilograms and a rolling speed of 10 meters per second. Cannonball has a mass of 5.44 kilograms and a rolling speed of 13 meters per second. The bowling ball has a greater momentum to knock down the column than the cannonball. Which of these two colored carts can be stopped by the solid cart? Can this solid cart of coal can stop the both other carts when they collide? Both will be pushed at the same force and same speed of 1.2 meters per second. The blue cart has a 65 kilograms of mass. Let's try another one. A gray cart has 89 kilograms of mass. The solid cart can only stop blue cart because it has a lesser momentum. A tricycle is parked at the side of the road, waiting for some passenger, with its total mass of 152 kilograms. The velocity is 0 because it's not moving. Transpose, use the formula. Momentum is equals to 152 kilograms multiplied by 0 meter per second. Obviously, you will get a product of 0 kilogram meter per second. Yes, remember the simple definition of momentum. Momentum is a mass in motion. An object that is not moving has no momentum. Two vehicles are going to collide to each other. A purple car and a red car. Which car has a greater momentum and which car would have dealt a greater damage after the collision? A purple car has a mass of 1,354 kilograms with a speed of 33.33 meter per second. A red car has 1,590 kilograms and its speed was 30.56 meter per second. Calculate the momentum of a purple car. The momentum of the purple car is 45,128.82 kilogram meter per second. Calculate the momentum of the red car. The momentum of the red car is 48,590.4 kilogram meter per second. The red car has the greater momentum. The purple car will have more damage. There are more complex solutions to calculate the momentum of two or more objects that contact each other. It is called the conservation of momentum. And there are types of collision like elastic, inelastic, and perfectly inelastic. Some points to remember. Momentum is a mass or object in motion. There are two variables for the basic understanding of momentum: mass and velocity. These two are multiplied. Both mass and velocity are direct proportional. Any greater variable will increase the value of momentum. Greater mass is equals to greater momentum. High velocity will give you a higher momentum.